Imagine a place where even light forgets how to escape. Out there, beyond the familiar rivers of stars, lies a silence so complete that it swallows everything sound time and the very idea of direction. It's a silence not of absence, but of power, the kind of quiet that bends the universe around it, like a weight pressing into the fabric of existence itself. This is where gravity becomes something else, entirely no longer a gentle pull, but a hunger, the hunger of darkness. Hey guys, tonight we're taking a slow journey toward that hunger. We'll drift through the mysteries of the most powerful black holes ever known. Explore what happens when time dissolves into gravity, and ask what might be living or unliving inside them. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. It helps this quiet corner of the cosmos reach others who might need it. And while you're here, I'd love to know, where are you listening from tonight? What time is it in your corner of the world? Maybe it's midnight in Tokyo, or the early hours before dawn in Buenos Aires. Wherever you are, imagine the night stretching across space, the same sky above you, reaching out to distant galaxies where black holes hum invisibly in the dark. Now, if you're ready, let's begin. When you look up at the night sky, the stars appear eternal. They shimmer constant and patient, as if nothing could ever disturb their light. But the truth is more fragile. Every star, no matter how bright, carries a secret countdown within it, a slow, inevitable fall inward. Some end quietly fading into white embers. Others die with such force that they tear space apart, collapsing their own mass into something smaller than imagination allows. A black hole is what remains when gravity wins. It's not a thing, not in the way we understand things. It's an event, a place where matter, space, and time collapse into a single, endless fall. The edge of it, called the event horizon, is the boundary between somewhere and nowhere. Beyond it, nothing returns. If you could drift near one, your sense of time would begin to stretch. Seconds would lengthen into centuries. Your heartbeat would slow until it matched the rhythm of the cosmos itself. And if you crossed that invisible line, that horizon of no return, you would vanish not suddenly, but softly. The outside world would see you fade, frozen in place, even as from your own perspective, you would fall forever. Black holes are paradoxes made real. They are infinitely small, yet infinitely dense. They hide, but they shape everything around them. Entire galaxies, spinning whirlpools of stars, orbit their invisible presence. The Milky Way itself, our quiet home, moves in gentle obedience to one of these titans. Sagittarius A, times a supermassive black hole, 4 million times heavier than the Sun. It sits in the galactic core, surrounded by clouds of stars that whirl like sparks around a campfire that's been burning for billions of years. You can't see it, but you can feel it. Its gravity stretches across 60,000 light-years, holding the Milky Way together. Without it, the spiral of our galaxy would drift apart into the cold void. It's strange, isn't it? The most powerful force in our home galaxy, the very heart that binds us, is invisible, silent and endlessly hungry. Astronomers have learned to watch the darkness indirectly. They look at the dance of stars nearby, how they wobble, how they accelerate, and from those movements they draw the shadow's outline. In 2019, we saw one for the first time, not the black hole itself, but its shadow, glowing faintly in orange light from matter spinning near the edge of oblivion. That image, the first photograph of a black hole, came from a galaxy called M8755 million light-years away. What you're seeing in that image isn't the black hole, but the last light it devours. Gas and dust swirl around the event horizon at nearly the speed of light, heated until they blaze brighter than entire galaxies. And then, just before crossing the line of no return, the light bends back on itself, trapped, twisted, forming that glowing ring around a perfect dark center. Some call it a doorway, others call it the end of everything, but in truth, it might be both. Black holes challenge the very foundations of physics. They blur the lines between time and space, between matter and energy. Einstein predicted their possibility through his equations, but he didn't believe nature could ever create one. It felt too extreme, too absurd. Yet the universe, in its quiet indifference, creates them all the time. They are born in the deaths of stars and grow by feeding on anything that drifts too close. Dust gas planets, even light itself. And the bigger they grow, the stranger they become. Some are so vast that they could fit billions of suns inside their horizon. Some spin so fast they drag space around them like a whirlpool, twisting time into knots. And still they keep growing, not just swallowing matter, but reshaping the universe with their gravity. When we think of darkness, we often imagine emptiness. But black holes are not empty. They are full, filled, with gravity so intense that even the concept of inside begins to lose meaning. The fabric of reality folds inward until space and time become inseparable. Some scientists believe that at the very core, known as the singularity, the known laws of physics simply stop. Equations break down. Infinity takes over. What lies there in that unreachable center? Is it truly an end, or something beginning in disguise? Could the singularity be a gateway, not to death but to transformation? Some theories whisper that black holes might be the birthplaces of new universes, budding off like seeds from an older tree. If that's true, then every black hole is not only a grave, but a womb, the silence from which another cosmos might one day awaken. For now, though, all we can do is watch from afar, through telescopes and radio waves, through mathematics and imagination. And as we watch, we learn that the universe isn't a story of light versus dark, but of light within the dark, flickering, bending, always becoming something new. So tonight, as you lie there listening, let yourself drift toward that quiet pull. Picture the stars, dimming one by one, the night deepening until it becomes infinite. Somewhere out there, the hunger of darkness waits, not as a monster, but as a mirror of the universe itself, endless, patient, and strangely peaceful. Now, take a slow breath. Let the thought of gravity cradle you, not as a threat, but as a promise that even in the deepest dark, something holds you close. Through space, bathing planets and dust clouds in radiance. Every sunrise we've ever known, every glow that has ever fallen across an ocean or a mountain, comes from this quiet nuclear balance. A star's life is, in essence, the universe learning how to shine. But all light, no matter how bright, must one day fade. Deep inside a massive star, the fusion that sustains it slowly consumes its fuel. Hydrogen becomes helium. Helium becomes heavier elements, and the star's core grows denser with each transformation. Like a great heart, beating slower and slower, it begins to struggle under its own weight. Gravity presses inward, while radiation pushes outward, the two locked in a delicate standoff that defines the star's existence. Then one day, the balance breaks. The fuel runs out. Fusion falters. the heart stops, and gravity, relentless, patient gravity, finally claims its victory. In that instant, the core of the star collapses with unimaginable speed. In less than a second, matter that once filled millions of kilometers compresses into a sphere barely the size of a city. The outer layers, no longer supported by internal pressure, fall inward, too crashing into the core with a violence that releases more energy than our sun will emit in its entire lifetime. This is a supernova, the universe's grandest and most tragic explosion. To any distant observer, it would appear as a sudden, dazzling flare, a new star in the sky, brighter than all others visible even in daylight. But behind that radiance lies death, the last cry of a dying Sunday. Yet, even in this destruction, there is creation. Supernovas forge the heavy elements that make up everything solid: carbon in our cells, iron in our blood, gold in our jewelry. Every atom of your body was once inside a star that ended in such a collapse. You are in the quietest truth, made of stardust, scattered by cosmic death. But not all stellar deaths are the same. Some stars, especially the most massive ones, leave behind something even stranger. When their cores collapse, the pressure grows so extreme that atoms themselves are crushed. Protons and electrons fuse into neutrons, creating a neutron star, an object so dense that a teaspoon of its matter would weigh billions of tons. Its surface spins at hundreds of times per second, glowing with the ghostly rhythm of pulsars, celestial lighthouses marking the graves of suns. And beyond even that lies the final step, the point where no known force can resist gravity's pull. The collapse continues past all limits until space itself folds inward. There is no solid surface, no atoms, no boundary, only a region where everything falls toward a single, invisible point. A black hole has been born. Imagine this process unfolding in silence. From light to collapse, from collapse to darkness. The star's final breath is not a sound, but a wave rippling through the fabric of space-time, a gravitational sigh that travels across the cosmos. We can detect it now, faint and fleeting, through instruments sensitive enough to hear the tremors of the universe itself. When the collapsing core crosses its own event horizon, time, as far as we understand it, stops. To an outside observer, the dying star appears frozen, its light stretching, dimming, never quite fading. But inside, in that place where direction and distance lose, meaning the fall continues endlessly, the star becomes a point of infinite density, wrapped in the cloak of its own gravity. Astronomers have simulated these depths, capturing them in equations rather than telescopes. In those mathematical models, the universe becomes a strange mirror, one side full of luminous creation, the other of hungry annihilation. And between them lies only a moment, the blink in which a star implodes and the laws of nature bend into something unrecognizable. There's something deeply poetic in that transition. The same force that builds galaxies also destroys stars. The same gravity that shapes planets into spheres also crushes matter into nothingness. The universe doesn't choose sides, it simply changes form. Creation and destruction are not opposites. Here they are, the same process seen from two directions. If you close your eyes, you can almost picture it. A massive blue star, millions of times brighter than the sun, burning for eons in some distant galaxy. Around it, worlds orbit quietly, perhaps with oceans, winds, and watchers of their own. And then one night, on one of those worlds, the star blooms with light so intense it turns the darkness into day. For weeks, it shines brighter than everything else in the sky. Then slowly, it fades. What remains is silence. A single point of gravity, invisible, yet eternal, where a sun once burned. The ghosts of its light will wander through the galaxy for thousands of years, while the black hole it left behind waits patiently, devouring what drifts too near. In time, that black hole may merge with others. Their gravitational fields may intertwine, sending waves of invisible sound across the cosmos. And somewhere billions of years from now, a civilization might listen to those echoes, unaware that the melody they're hearing is the final heartbeat of a long-dead star. Perhaps that's what the universe truly is, not a place of endings, but of transformations whispered in the dark. Stars collapse not to vanish, but to change their role, from light-bearers to keepers of gravity, from radiance to remembrance. So as you rest tonight, let your thoughts drift to that cosmic rhythm, expansion and collapse, birth and silence. Every breath you take follows the same pattern. You inhale, the universe expands. You exhale, it falls back in. The same pulse that moves galaxies moves through you. In the quiet between those breaths, you can almost hear it, the faint sigh of a star becoming something new. The moment when light surrenders to darkness and darkness learns how to shine. Out there between the glittering arms of galaxies and the thin light of distant suns, drift entities so powerful that even the laws of nature kneel before them. They make no sound, they cast no shadow, and they emit no light of their own. Yet everything near them, gas stars, whole solar systems, moves according to their will. These are the black holes, invisible monarchs of the universe. We call them holes, but they are not empty. They are condensed gravity, pure curvature of space-time. The universe folding in upon itself so tightly that nothing, not even light, can climb back out. What we think of as a black hole is not a sphere of matter, but an event, a region where the rules of existence are rewritten. There isn't just one kind of black hole. Like living creatures, they come in sizes, in temperaments, and in histories that span billions of years. Some are the small and furious remnants of dead stars. Others are titans, ancient, slow, and patient, older than galaxies themselves. The smallest are known as stellar mass black holes. They form when massive stars collapse, as you heard in the last chapter. Their masses range from 3 to a few dozen times that of the Sunday. They drift like silent predators, often locked in orbit with companion stars. As they feed, they tear matter from their neighbors, heating it into a glowing halo called an accretion disk. It's the black hole's only visible footprint, a bright spinning ring of plasma shouting its presence into the void. If a stellar black hole could speak, it would not roar, it would hum, a deep gravitational tone slower than any heartbeat, resonating across thousands of kilometers of space. In fact, scientists have learned to listen to them. When two black holes orbit and merge, they create ripples in space-time gravitational waves that roll outward like sound through a dark ocean. These waves were first detected in 2015, confirming one of Einstein's most haunting predictions. Each wave we detect is a cosmic obituary, the death of two black holes that became one. Then, somewhere between the small and the impossible, there are the intermediate black holes. For decades, they were only speculation, too massive to be born from stars, too small to anchor galaxies. But evidence has begun to appear: strange X-ray bursts in dwarf galaxies, odd gravitational patterns in star clusters. These might be the missing link, the bridge between stellar collapse and cosmic creation. Their existence hints that black holes, like all living things, can grow feeding, merging, evolving. And finally, towering above all others are the supermassive black holes. They are the silent hearts of galaxies containing millions or billions of solar masses. Sagittarius, A times, the one at the center of our Milky Way, is one of them, a dark core 4 million times heavier than our Sunday. But there are larger ones, still, monsters so vast that their event horizons could swallow entire solar systems whole. Ton 618, one of the biggest ever measured, has a mass of 66 billion suns. Its gravity controls the fate of everything in a galaxy 10 billion light-years away. How can something so enormous be invisible? It's because a black hole doesn't shine, it bends. Its gravity warps the very path of light, curling it into circles. If you could see one up close, it wouldn't look like a hole at all. It would look like a glowing ring, distorted and trembling, as if the universe itself were being pulled into a mirror that reflects nothing back. For centuries, even the greatest minds doubted they could exist. The idea was born in the 18th century, when English philosopher John Michell and French mathematician Pierre-Simon Laplace proposed dark stars, bodies so massive that light could not escape them. But the term black hole wouldn't appear until the 1960 seconds, coined by physicist John Archibald Wheeler. By then, Einstein's general relativity had already predicted their existence mathematically, though even Einstein himself found them unsettling. He once wrote that such objects do not exist in the real world. But the universe, as always, had its own plans. When we finally began to detect them first through their gravitational pull on nearby stars, and later through X-rays and gravitational waves, our picture of reality deepened. Black holes are not cosmic accidents. They are fundamental to the architecture of the universe. Without them, galaxies would not hold their shape. Stars would drift away. Even time itself might not flow as we know it. There's a strange comfort in that. The most terrifying objects in existence are also the ones that make existence stable. They are both destroyers and anchors, sculptors of the night. Astronomers have even classified a new category, ultramassive black holes, hundreds of billions of suns in mass lurking at the centers of giant elliptical galaxies. They are so vast that light takes days to cross their diameter. Around them, stars orbit like fireflies around a mountain. We have no clear explanation for how they formed so quickly after the Big Bang, but one theory suggests they were born directly from the collapse of enormous clouds of primordial gas, the universe's first act of gravity made flesh. Sometimes people imagine black holes as cosmic vacuums, devouring everything in sight. But that's not quite true. If our sun were replaced by a black hole of equal mass, Earth would continue orbiting almost exactly the same way, just without sunlight. Black holes don't hunt. They simply wait. They are patience incarnate, feeding only on what drifts too close. And when something does cross that invisible line, time stretches into infinity. From the outside, you'd see the object slow down its light, red shifting until it fades into nothing. From within, though, the fall would feel swift, not falling into darkness, but through it. The horizon wouldn't feel like a wall, but a threshold. If the universe were a living thing, black holes would be its sleeping heartbeats, vast pauses between pulses of creation. Every galaxy has one. Every light bends to them. Every law of physics must account for them. We orbit unknowingly the quietest tyrants imaginable. So tonight, as you lie beneath the same stars that orbit Sagittarius A times, think about this. We are all in the pull of something invisible, not just gravity, but mystery itself. The universe doesn't show us its secrets easily. It hides them in silence, in shadow, in the invisible rhythm of the cosmos. Let your thoughts drift with that silence. The same gravity that anchors galaxies also anchors you not to destruction, but to wonder. Imagine, if you can, the Milky Way, seen from far outside it, a vast spiral of pale light, turning slowly in the black sea of space. At its center, not visible to any eye, sits something silent and magnificent, Sagittarius A, times the dark heart around which everything else revolves. From its invisible throne, it governs 400 billion stars, countless planets, clouds of gas and dust, and the very motion of our home galaxy. And yet it makes no sound, emits almost no light, and has no surface. It is a presence made entirely of gravity. If you could travel there, you would find it hiding in the direction of the constellation Sagittarius, near the crowded bulge of the Milky Way. Through a telescope, the region looks like a glowing fog, hundreds of stars packed so tightly that they seem to merge into one luminous swarm. But when astronomers studied those stars more carefully, they noticed something uncanny. They were racing around an empty point of space, moving so fast that only something extraordinarily massive could hold them in orbit. The motions betrayed the secret. At the very center, unseen, lurked a monster 4 million times the mass of the Sunday. The discovery was confirmed in 2002 after years of patient watching. Scientists mapped the orbits of individual stars, tracing elegant ellipses that looped around nothing. One star, called S2, completes its orbit in just 16 years, whipping through space at more than 5,000 kilometers per second. At its closest approach, it dives so near the invisible core that it feels 100 billion times the pull of Earth's gravity. Nothing else could do that except a supermassive black hole. And so we gave it a name, Sagittarius A*. The asterisk was an astronomer's shorthand, but it fits a tiny symbol for something beyond measure. The region around Sagittarius A times is not calm. Matter from nearby stars is drawn toward it, swirling in a vast accretion disk hotter than any furnace. Magnetic fields twist gas compresses, and some of it escapes as thin, luminous jets of radiation that shoot thousands of light-years into space. These flares blink unpredictably, like the heartbeat of a sleeping giant. In 2019, the Event Horizon Telescope, a network of radio observatories spanning the Earth, captured the first direct image of this galactic heart. It looked like a blurry orange ring, trembling at the edge of darkness. That ring is not the black hole itself, but the last light circling before the plunge. When you stare at that image, you are seeing gravity made visible, the bending of light around an abyss. Each photon completes several orbits before escaping toward us, carrying the shape of curved space-time as an imprint. What appears as a simple glow is in fact a portrait of distortion, the geometry of the universe, folding in on itself. Around Sagittarius A times, stars move in graceful chaos. Some are flung outward at tremendous speeds, becoming hypervelocity stars that leave the galaxy forever. Others are shredded their gas, spiraling inward and releasing bursts of X-rays that flicker like cosmic campfires. Every flare we detect tells a story of something torn apart, transformed into energy, and finally swallowed by silence. And yet, despite its violence, this black hole is strangely benevolent. Without it, the Milky Way might never have formed as it did. Its gravity anchored the first clouds of gas, guiding the spiral arms into shape. It acts as both the center and the stabilizer, the unseen heart, keeping the galactic body in rhythm. Even now, as we drift on one of those spiral arms 30,000 light-years away, our solar system dances to its gravitational song. Every orbit we make around the galaxy, one full turn every 225 million years, is a waltz led by Sagittarius A*. Some astronomers like to imagine it as an ancient memory of the early universe, a relic from the first generation of stars grown enormous through endless feasts. Others suspect it might have been born differently, formed directly from collapsing clouds of primordial matter. Either way, it has been there longer than the sun, longer than Earth, longer than life itself. When the first simple cells on our planet were learning how to divide the black heart of the galaxy, was already turning in silence. If you could fall toward it, the journey would be slow at first. You would pass through crowded fields of stars, through dusty veils of interstellar clouds, through regions where radiation hums softly like wind. The closer you come, the more the starlight bends. Near the center, space itself begins to curve so steeply that all directions point inward. And then, just beyond sight, the event horizon waits not a wall but a boundary of knowledge. From there, no message, no light, no memory ever returns. Scientists sometimes describe Sagittarius A times as a sleeping black hole because it feeds only occasionally. Most of the time it dozes, surrounded by calm darkness, disturbed only by the slow drift of gas clouds. But every few decades it wakes, flashing briefly, as it consumes something that wandered too near. Then it quiets again, as if nothing happened. There's a poetic symmetry in that. The galaxy breathes, and its heart answers. Light travels outward, gravity calls it back. Between them lies everything we know. If you step outside tonight and look up toward the center of the Milky Way, that dense ribbon of silver stretching across the sky, you are looking in the direction of that silent heart. The light from those stars left them tens of thousands of years ago, long before the first human stories. Yet the same gravity that holds them holds you. So breathe with it now. Inhale as the galaxy spins, exhale as it drifts through the ages. Somewhere far away, the darkness turns slowly, patiently, forever. And in that turning, the Milky Way keeps its balance, a luminous spiral around a center that no one can see. Let the thought settle. The universe has a heart, and it beats quietly behind every star. Imagine standing at the edge of forever. Before you stretches a curve in space so deep and steep that even light itself, the fastest thing in existence, cannot climb out. There is no wall, no glowing gate, no sign that says, "Here ends the universe." There is only the subtle, invisible line where gravity becomes absolute. This is the event horizon, the boundary between what can be known and what must remain hidden. The phrase, "point of no return," has been used so often in human stories, in wars, in love, in moments of risk and discovery. But here among the stars, it takes on its most literal meaning. The event horizon marks the place where time and space exchange, roles where moving forward means falling inward forever. Crossing it is not death in the usual sense. It is a surrender to gravity so complete that even information, even memory, cannot escape. From far away, the event horizon looks peaceful. Matter swirls around it in glowing ribbons. Light bends in graceful arcs, and the black hole's outline shimmers like a halo of heat. But this serenity is deceptive. Near the horizon, space stretches and time distorts. If you were watching an object fall toward it, a satellite, a star, or even a person, you would never see them cross the line. Their motion would slow redshift and finally fade, frozen forever at the edge of invisibility. And yet, from their own perspective, the fall would continue without pause. In a few brief moments, they would slip through the boundary and vanish, leaving behind only their last image eternally suspended in space. Two realities at once, one seen, one felt. That's the paradox of the event horizon. Astronomers describe it in mathematical precision: the radius of the Schwarzschild solution, a place where escape velocity equals the speed of light. But to imagine it poetically, think of it as the skin of a shadow, not a surface, but a transition, the membrane between being and unbeing. Beyond it lies the singularity, a realm where density and gravity become infinite and all known equations break. But even the horizon itself is fascinating. Physicists have discovered that it behaves almost like a living thing. It has temperature, it radiates, faint energy. It can grow or shrink depending on what it consumes. In a way, it's a kind of cosmic organism, a breathing boundary between physics and mystery. Stephen Hawking once described the event horizon as a prison with a slow leak. His famous theory of Hawking radiation suggested that quantum effects at the edge cause black holes to lose tiny amounts of energy over time. If true, then, even the mightiest black holes are not eternal. They evaporate atom by atom over unimaginable spans of time until perhaps they disappear, entirely leaving behind only faint radiation as their final whisper. The idea still unsettles physicists. How can something that allows no escape also evaporate? Where does the information go? If the horizon slowly releases particles, does it also release the secrets of what fell inside? Or are those secrets gone forever, dissolved into cosmic noise? This question, the information paradox, has haunted science for decades. It's more than a riddle of equations. It's a question about the nature of reality itself. If information can truly vanish, then the universe might not be a consistent system after all. Some theories suggest that the information remains encoded on the surface of the event horizon, smeared across it like a hologram. Others whisper that what we call the inside of a black hole is not a void but a mirror, reflecting everything back in ways we can't yet perceive. To visualize the horizon, close your eyes and imagine a whirlpool not of water but of space-time. Near the center, the current accelerates until every ripple of light, every signal, every attempt to resist is dragged inward. At a certain point, escape becomes impossible, though the surface of the whirlpool remains deceptively calm. The event horizon is that surface. Beneath it, reality tumbles toward the singularity. Above it, time continues as usual. If you could hover just above the horizon safely somehow, you would see the universe distorted beyond recognition. The stars behind you would bend into arcs, their light stretched and twisted into spirals. The glow of the accretion disk would curve around the black hole, wrapping it in a luminous ring. The sky would appear to fold in on itself, every direction pointing toward the center. You would feel the slow pull, not as motion but as certainty, as if gravity were a thought in your mind urging you inward. But no one could survive that close. The tidal force's differences in gravity from head to toe, would stretch your body atom by atom, a process poetically called spaghettification. Yet if you were falling freely, you wouldn't feel it. You'd be weightless, drifting peacefully through the threshold, unaware that the outside universe has already lost sight of you. In the deepest sense, crossing the horizon might feel like falling asleep, a surrender, a letting go. For billions of years, countless stars, planets, and clouds of gas have crossed that line. Each one has left its mark on the horizon, expanding it slightly, deepening the curve of space-time. In this way, black holes grow like memory. Each act of falling adds a story to their invisible skin. Some physicists even describe the surface area of the horizon as a measure of entropy, the amount of disorder or the number of ways information can be stored. If so, then the event horizon is not only the edge of physics, it's also the ultimate archive of the universe. There's beauty in that thought. Nothing that ever was is truly lost. It merely changes form, written in patterns we can't yet read. The light that vanishes may one day return as radiation, as energy, as the raw fabric of future stars. So tonight, as you close your eyes, imagine yourself standing at that cosmic border between the known and the unknowable. Feel the gravity of silence pulling softly at your thoughts. Everything you've ever been, every memory, every breath, moving gently toward stillness. And then let go. Let the mind drift across the horizon, not to vanish, but to rest, as if sinking into the quietest night the universe has ever known. Because maybe that's what the event horizon really is. Not a wall of destruction, but the moment when everything stops resisting and finally becomes part of the whole. Imagine for a moment that you could survive the journey. You are no longer an observer watching the black hole from a distance. You are the traveler drifting toward it. The stars behind you elongate into thin, trembling lines. Ahead, the center of the galaxy opens like an infinite mouth, silent and patient. The pull is irresistible, but strangely not violent. You don't fall as much as you are carried, cradled in a current of gravity that feels more like fate than force. At first, nothing seems different. The vastness of space still surrounds you. The stars still glimmer. But gradually the sky begins to curve. Light, once straight and obedient, starts to bend around you. It forms rivers and arcs flowing toward the same dark point that now dominates your view. That point does not grow larger. It grows deeper, like a hole cut into the fabric of existence. The closer you come, the slower everything else appears to move. Time itself begins to ripple. To those far away watching from the safety of the universe, you seem to slow down. They would see your ship crawl, its signals stretched and redshifted until they fade completely. You would appear frozen at the edge of the event horizon, a ghost locked in eternal descent. But from within your own perspective, the fall continues smoothly. Seconds pass normally. Your instruments still tick. It's only the outside world that drifts into stillness. This is gravitational time dilation, one of Einstein's most beautiful and unsettling ideas. The stronger gravity becomes the slower time flows. Near the event horizon, seconds for you might equal centuries elsewhere. Fall deeper and the difference grows infinite. It's as if you are sliding down a slope made of time itself, watching the entire history of the universe speed past you. The light around you begins to twist into ribbons, the accretion disk, that swirling storm of incandescent matter, blazes all around, but its glow is warped into impossible shapes. Ahead, the black hole's shadow remains black, yet behind it, stars begin to reappear, their light bent forward by the hole's gravity. You see the same star twice, once where it is, once where its light curves around the darkness. The universe folds upon itself, and for a moment you can see all directions at once. If you were falling towards Sagittarius, say, times this spectacle would last minutes, maybe hours. If toward a larger black hole like TON 618, it could last days. The bigger the black hole, the gentler the gravitational gradient near its horizon, meaning that paradoxically you might cross it without noticing. There would be no jolt, no impact, no sudden death. The border between light and shadow would feel like mist, not a wall. And then you would pass through. Inside the laws of physics, the ones you have trusted all your life begin to unravel. Space does not behave like space anymore. Every direction points inward. Every moment is a movement toward the singularity. You are no longer in time. You are time stretching, bending, falling. Some theories suggest that light inside a black hole doesn't vanish. It just circles, endlessly trapped in a closed loop. Others say space itself collapses into a single line thinner than thought. No one truly knows. What you might see if vision still had meaning is the universe collapsing into brightness. The darkness ahead would shimmer, then dissolve into a field of pure energy. It would be less like falling and more like dissolving. The body, the ship, the atoms, all would lose distinction, stripped of individuality and shape. You would become motion, pure and silent part of the gravity itself. For those who fear such an ending, it sounds like annihilation. But consider another possibility. Perhaps it is union. The same matter that once made you the same particles, forged in stars, breathed in by others, scattered through oceans and air, would now merge with the most fundamental flow of the cosmos. You would not disappear, you would be rearranged. There are echoes of this in mysticism, in philosophy, in the quiet intuition that everything eventually returns to where it came from. Falling into a black hole might not be an erasure, but a homecoming. The universe taking back what it lent out for a brief moment of consciousness. The great paradox is that from your perspective, you never actually reach the singularity. Time slows infinitely as you approach it. The closer you get, the longer each instant lasts until the fall stretches into eternity. The journey becomes a horizon of experience never completed, always continuing. You are suspended between motion and stillness, falling forever through light that bends and lengthens into infinity. From the outside, of course, the story has already ended. The universe has moved on. The black hole has absorbed your energy, its event horizon slightly larger than before. The ripples from your final fall spread outward as gravitational waves passing through gas clouds, stars, and perhaps one day, through detectors on Earth, a faint whispering echo of your descent. But to you, within that eternal instant, everything still exists. You see the galaxy above you, the light folding into spirals, the faint afterglow of creation itself. The boundaries between moments dissolve until there is only one endless, luminous, peaceful. And maybe in that final timeless moment, the last thing you feel is not fear, but awe. The understanding that everything you, the stars, the black hole, is part of the same fabric, woven and unwoven, again and again. The hunger of darkness is not cruelty. It is the universe remembering itself. So as you drift tonight into your own sleep, your own gentle descent into inner darkness, imagine that same softness guiding you. Let go of resistance. Let the edges blur. Fall not into fear, but into light folding upon itself. The fall never ends, and that is its grace. Because in the quiet heart of gravity, even falling is a kind of rest. Imagine watching a clock near a black hole. Its hands still turn, but slower, each second dragging its feet like a tired traveler through deep space. To the observer, far away, the ticking almost stops. The clock's rhythm becomes a whisper, stretched thin by gravity. It is not broken. It's simply caught in the deep current of space-time. The closer you move to the black hole, the slower. Everything seems to happen, not just motion, but existence itself. This is gravitational time dilation, one of Einstein's most delicate insights. Time, that invisible river we so often mistake for constant, is not the same everywhere. It bends, flows, and stretches under the influence of mass. On Earth, we barely notice. The difference between your head and your feet is a fraction of a nanosecond each year. But near a black hole, this effect becomes profound. Time itself becomes fragile. For a moment, try to imagine standing safely on a planet orbiting close to Sagittarius A, times the black hole at the center of our galaxy. The planet completes one orbit every few hours, its surface bathed in faint blue light from the glowing accretion disk. To you, 1 hour passes normally, but for a distant observer, someone watching from far away beyond the black hole's influence, days or weeks might have gone by. Time here moves at a different rhythm, as though the universe were playing two melodies at once. In 2014, a film called Interstellar captured this idea in haunting beauty. The astronauts landed on a planet near a black hole named Gargantua. For every hour they spent there, 7 years passed on their ship above. Though fictional, the concept was scientifically sound. Near enough gravity time really does slow that dramatically. The deeper you are in the well of space-time, the slower the river flows. And if you were to fall beyond the event horizon itself, time would no longer make sense at all. You could not measure it, because the act of measuring requires light, and light can no longer move outward to mark your moments. To the outside universe, you would appear frozen forever. To yourself, however, you might feel that time continues, a quiet, infinite instant, stretching towards something you can't name. It's a strange paradox. Black holes destroy time for everything that enters, yet they also preserve it, freezing each moment on their surface. Every object that falls in remains, from our perspective, suspended at the edge forever mid-fall. In a way, black holes are museums of time, holding countless moments in eternal pause. Some physicists even describe the event horizon as a kind of cosmic archive storing the history of everything that has ever crossed it. Einstein once said that for those who truly understand physics, the distinction between past, present, and future is only a stubborn illusion. The universe does not flow, it is. Every moment exists simultaneously in space-time, like pages in a book that only consciousness reads in sequence. Near a black hole, that illusion begins to crumble. You glimpse the truth. Time is not a march, but a landscape. Gravity lets you walk along it in strange directions, sometimes even looping back toward yourself. Imagine what that would feel like, to experience a single second stretching into infinity, to live inside the space between heartbeats. The sensation might not be terrifying, but deeply peaceful. No rush, no urgency, no separation between before and after. Just pure awareness suspended in the slow hum of existence. Some scientists believe that this bending of time near black holes may explain why they are so stable. From their own perspective, black holes age incredibly slowly. A supermassive black hole might live for trillions of years before evaporating, but from the outside, that lifetime seems eternal. The larger the black hole, the slower its clock ticks, so slow that even the universe's end may arrive before it finishes a single moment of its own time. Think about that somewhere out there, in the deep heart of a galaxy, there may exist a place where time has nearly stopped since the dawn of creation. While galaxies have formed and died, while stars have lived and vanished, that black hole has simply been. In its frame of reference, perhaps it still remembers the first light of the Big Bang. To fall into such an object would be to slip not just into darkness, but into the oldest dream of the cosmos. Philosophers have long wondered what time really is, whether it flows because we move through it or because we become it. In the presence of a black hole, such questions turn literal. You do not experience time. You are time stretched thin, woven into the geometry of gravity itself. The pulse in your chest, the thought in your mind, both are echoes of the universe's expansion, slowing, bending, folding back on itself. Maybe that's why thinking about black holes feels oddly meditative. They strip away everything we think we know, distance, speed, sequence, until all that remains is stillness. The kind of stillness that hums with infinite depth. To gaze into a black hole, even from imagination, is to stare at time itself, taking its last slow breath. As you listen to these words, time is passing differently for you and for me. Your heart sets its own rhythm. Your thoughts drift at their own pace. But somewhere, a black hole is stretching those same seconds into eternities, pulling on the threads that tie all things together. You, me, the stars, we're part of the same clock, ticking in different ways. So when you close your eyes tonight, let the ticking fade. Let time dissolve into a soft current. There's no rush, no schedule, no ending. Just gravity and the slow unfolding of everything that ever was. Because even when time dies in the shadow of a black hole, the universe keeps breathing quietly, endlessly in rhythms we can almost hear. If you could somehow float near a black hole and listen, what would you hear? The answer paradoxically is everything and nothing at all. Space itself does not carry sound in the way air does. There are no molecules to vibrate, no atmosphere to tremble with noise. Yet the universe has its own language spoken through waves and ripples that stretch across the fabric of space-time. Near a black hole, that language grows deep, slow, and hauntingly quiet. You wouldn't hear a roar or a scream, as popular imagination might suggest. You'd hear a kind of absence, the stillness between notes, the pause after an orchestra fades. The silence near a black hole is not emptiness, it's density. It is silence so heavy that even imagination hesitates to break it. But in that silence, the universe hums in other ways. Black holes speak through gravitational waves, those invisible tremors in space-time, first predicted by Einstein over a century ago. When two black holes spiral toward each other, their gravity distorts the very geometry of the cosmos. The distortion travels outward at the speed of light, not as sound, but as motion itself, the universe flexing. In 2015, the LIGO Observatory on Earth recorded one of these cosmic murmurs for the first time. It wasn't an explosion or a crash, but a brief rising chirp. That delicate note, less than a second long, came from two black holes merging over 1 billion light-years away. Their collision released more energy than all the stars in the observable universe combined. Yet it passed through us so gently that only the most sensitive instruments could feel it. Imagine that the loudest event in existence experienced as a whisper. Astronomers can now convert those gravitational waves into sound we can hear. When they do, the result is eerie, a deep, ghostly tone, like the lowest note of a cello vibrating through eternity. Each one corresponds to a cosmic event, two black holes dancing their final waltz before becoming one. The sound of nothing, transformed into something we can almost understand. If we could compress the silence of a black hole into a frequency, it would be lower than human hearing, a note so deep it takes entire minutes to complete a single vibration. And yet, in its rhythm, there is harmony. Every merger, every ripple, every faint tremor adds another chord to the grand composition of the cosmos. Space is not quiet. It's just that we've not yet learned how to listen. Even in their solitude, black holes interact with their surroundings. As matter spirals, inward friction and magnetic fields generate powerful radiation. The result isn't sound, but light X-rays and gamma rays flickering from the accretion disk like embers in a fire. If these could be translated into audio, they'd sound like static, layered over a slow heartbeat. Each flare would be a note, a pulse, a story of something consumed and transformed. Scientists at NASA once took X-ray data from the Perseus galaxy cluster, home to a massive black hole, and converted it into sound. What emerged was a tone 57 octaves below, middle C, billions of times deeper than any instrument could play, a vibration too slow for human ears, yet undeniably real. The black hole was singing in its own language, through waves of pressure rippling across space, a hymn of gravity. Perhaps that's what makes black holes so hypnotic. They embody silence and motion at once. They are perfect contradictions, infinite noise trapped in infinite stillness. When you imagine standing near one, you can almost feel the vibrations humming through your bones, not painful, but enveloping. The body becomes an instrument tuned to the cosmos, resonating with forces far beyond comprehension. If consciousness was sensitive enough, maybe we would hear this hum all the time. The universe is never truly silent. Even here on Earth, the atoms in your body vibrate with energy. The planet's magnetic field thrums faintly, and the background radiation from the Big Bang still hisses at the edge of space. Everything vibrates from the smallest quantum particle to the largest black hole. The difference is only scale. Imagine now drifting in your ship close enough to the event horizon to see the light curve but far enough to remain safe. Around you, the stars distort into spirals. The glowing disk of infalling matter blazes silently, but your instruments translate the energy into faint tones. A deep rumble, steady and endless, like the breathing of a sleeping giant. Then for a heartbeat, a sharp tremor, a burst of radiation as a fragment of gas plunges into the void. It's gone before you can register it, leaving only a long echo. The universe clears its throat and then falls back into quiet. This is the sound of nothing, not empty silence, but the hum of creation itself, continuing unseen. Every ripple, every fluctuation is a note in an eternal composition. You are hearing gravity composing poetry. Philosophers once said that music is the movement of time made audible. Perhaps black holes are the opposite, the stillness of time made visible. Their silence is not the absence of sound, but the presence of infinity. So when you listen tonight to the wind outside your window, to your own breath, to the faint ringing in your ears, know that you're hearing the same universe that hums around black holes. The frequencies are different, but the rhythm is the same. Every atom, every planet, every being vibrates with that same cosmic pulse. Close your eyes and listen. Beneath the noise of thoughts and the chatter of the day, there is always something quieter, something older, something infinite. It's the same hum that fills the darkness between stars, the sound of nothing, which is in truth the sound of everything. Every living thing in the universe needs to feed. Stars devour hydrogen planets, absorb sunlight galaxies, swallow each other whole. But no hunger is as endless, as patient, as absolute as that of a black hole. It doesn't hunt or chase, it waits. And the universe, sooner or later, always gives it something to consume. When gas and dust drift too close, gravity begins its slow work. The particles spiral inward, colliding, compressing and heating until they glow brighter than anything else in the cosmos. This swirling torrent of matter is called an accretion disk, a luminous halo that circles the black hole like a crown of fire. From far away, it looks like the black hole is wearing light, but that glow is a side effect of destruction. Each particle in the disk is screaming silently as it loses energy, drawn ever closer to the point of no return. It is a cruel and beautiful process. The disk can reach millions of degrees hotter than the surface of any star. Its inner edge spins at nearly the speed of light, whipping around the black hole hundreds of times every second. Magnetic fields twist through it like invisible snakes, accelerating jets of particles outward in thin blazing beams that can stretch for thousands of light years. These jets are the black hole's paradoxical heartbeat streams of light and matter, escaping from a creature that otherwise allows nothing to escape. You could think of it as feeding and breathing at once. The black hole inhales matter, and the energy released during the process exhaled back into the universe as light and radiation. This cycle of consumption and emission is one of the great engines of cosmic evolution. Without it, galaxies would stagnate. With it, they shine. In that sense, black holes are not simply destroyers. They are creators in disguise, sculptors of galaxies. Their hunger shapes the cosmos itself. As they consume, they regulate star formation. When they feed too greedily, the radiation and jets they emit blow away the surrounding gas, halting the birth of new stars. When they starve, the galaxy quiets, dimming into stillness. Life, light and order all dance to the rhythm of their appetite. Imagine watching such a feast unfold. From a safe distance, perhaps hundreds of light years away, you see a distant quasar, a black hole in the act of feeding so violently that it outshines entire galaxies. Its light, older than Earth, flickers through space with the steadiness of a heartbeat. The core of the galaxy blazes, the jets pulse, and within that distant fire, particles are annihilated, transformed, reborn as radiation. The black hole is eating, and the universe glows from the meal. What happens to the matter that crosses the horizon? We can only guess. Some physicists describe it as being compressed beyond recognition. Others imagine the atoms stretched into long threads, spaghettified in the poetic language of relativity, before being pulled apart into energy. Nothing escapes, not even the memory of what once was. But the energy of the fall radiates outward, first announcing the moment of consumption like a flare across eternity. And still the black hole does not change its pace. It does not hurry, does not tire. It waits centuries, millennia, aeons for its next meal. The debris of stars and nebulae drifts toward it, orbiting for eons before finally succumbing. Even the smallest bite, a planet, a comet, a handful of atoms, is enough to keep its hunger alive. There is a strange serenity to that patience. The black hole doesn't desire because it doesn't need to. Gravity is not emotion, it's inevitability. Everything that comes close enough must surrender. In the grand scale of the cosmos, that surrender isn't tragic, it's simply balance. The light that dies here gives birth elsewhere. The energy released by feeding black holes goes on to heat interstellar gas seed, new stars, and power the life cycles of entire galaxies. Astronomers have witnessed this cosmic feeding firsthand. In 2018, telescopes around the world captured the death of a star that wandered too close to a supermassive black hole 20 million light-years away. Over weeks, its light flared, peaked, and slowly faded, a meal consumed. The scientists called it a tidal disruption event, but in the language of poetry, it was a celestial offering. One sun sacrificed so that the galaxy's heart could glow. On Earth, in our own quiet corner of the Milky Way Sagittarius, A-Times occasionally stirs. Every few decades, it consumes a small cloud of gas or a lost asteroid. The resulting flash, detectable in X-rays, lasts only a few hours before fading back to darkness. Each flicker is a reminder: the heart of our galaxy still beats, still feeds, still holds us all within its gravitational embrace. Even black holes have limits, though. Once the surrounding matter is gone, they fall into dormancy, silent, invisible, waiting for something new to wander by. Some have slept for billions of years, their accretion disks cooled, their jets extinguished. But given enough time, everything moves again. A nearby galaxy will drift closer, a star will fall, and the feast will begin anew. The hunger of darkness never ends. It merely rests between courses. If you think about it, there's a kind of peace in that rhythm. Creation and destruction aren't opposites. Here they're steps in the same dance. The black hole consumes, and in doing so, it returns energy to the cosmos. Light born from annihilation illuminates worlds that will one day face their own darkness. Tonight, as you breathe slowly and listen, imagine that same rhythm echoing within you. Every inhale a gathering of the universe, every exhale a quiet release back into the void. We are not so different from black holes. We take in, we let go, and somewhere in between we shine. So let the thought settle in you like gravity, gentle, steady, endless. The universe feeds upon itself, but not with cruelty, with purpose, with balance. Every act of falling is also an act of becoming. And in that understanding, even the hunger of darkness feels less like destruction and more like love. There is a strange contradiction at the heart of the universe. The darkest objects ever discovered, black holes, can also become the brightest. When a supermassive black hole feeds the storm of energy it releases, turns the surrounding galaxy into a lighthouse visible across billions of light years. These are quasars, the most radiant beacons in existence, the proof that even darkness can learn how to shine. The word quasar is short for quasi-stellar radio source. When astronomers first found them in the 1950 seconds, they appeared as mysterious pinpoints of light. They looked like distant stars, yet their spectra revealed something impossible. They were moving away at tremendous speeds, much faster than any star could. Over time, scientists realized these tiny lights were not nearby at all. They were the blazing cores of galaxies, each one powered by a black hole billions of times heavier than the Sunday. Imagine standing far out in the void and seeing one of them. You would not see a quiet glow, but a roaring river of brilliance, blue-white light pouring from the galaxy's center, brighter than the combined light of 1 trillion suns. Jets of plasma, each hundreds of thousands of light-years long, would stretch into space like luminous spears. You would not need to imagine sound, for the energy itself would vibrate through your bones if you could be close enough, a low cosmic hum that says, "I am here, I am burning, I am endless." A quasar's power comes from its accretion disk. Gas falling toward the black hole is crushed and heated until it releases torrents of radiation. Only a tiny fraction of that matter actually crosses the event horizon. The rest is transformed into light. In some quasars, the disk glows so fiercely that it can outshine the galaxy around it by 1,000-fold. For astronomers, it's as if the black hole wears a halo, an impossible crown of fire born from destruction. The most distant quasars we've found date back to when the universe was less than 1 billion years old. Their light has traveled for more than 13 billion years to reach us. When we look at them through telescopes, we are looking into the universe's childhood, a time when the first galaxies were still forming, when stars were young and heavy, and when black holes grew greedily from the chaos. Quasars tell us that darkness and light have been dancing together since almost the beginning. One of the brightest known is 3C 273, located in the constellation Virgo. If it were as close as our nearest star, it would shine brighter than the sun and erase night from the sky. Its energy output is so vast that even the narrow beams of radiation it sends into space can pierce intergalactic dust and reach us intact. And yet, at its center lies nothing visible, just a silent black hole spinning in its own gravity. There is poetry in this paradox. The thing that allows no light to escape also creates the most spectacular light show in existence. Destruction becomes illumination. The act of falling becomes creation. A quasar is not merely an object. It's a moment of cosmic transformation where matter and energy trade identities. From Earth, quasars appear small, tiny sparks in a sea of darkness, but their brightness carries messages across the cosmos. Astronomers use them as cosmic lighthouses, measuring how space itself expands. The light from distant quasars passes through clouds of gas on its journey, revealing what the universe was made of eons ago. In that way, black holes, those devourers of matter, become storytellers, preserving the memory of creation in their luminous outbursts. If you could hover near one, the view would be surreal. Around you, the disk would blaze with white-blue light hotter than any star. Arcs of lightning would twist through the plasma, sculpted by magnetic fields that snap and reconnect with every rotation. The jets would surge above and below you, columns of particles moving almost at the speed of light. From within that maelstrom, you might glimpse the black hole's shadow, calm, centered, absolute, as if the universe were meditating while the storm rages around it. The scale of energy is hard to grasp. In 1 second, a quasar can release more power than the sun will in 10 billion years. Yet this fury is temporary. Eventually, the black hole runs out of fuel. The disk thins, the light fades, and the galaxy settles into quiet adulthood. What remains is a gentle core, a sleeping giant, like Sagittarius A, time's waiting for the next meal to wake it. The brightness we see now is the echo of an ancient feast, long finished, but still glowing as its light travels toward us. Sometimes I think of quasars as the universe's heartbeat, sudden surges of vitality that remind us creation isn't a single event but a rhythm. The cosmos breathes in darkness and exhales light. Each quasar flare is an inhale, a pulse, a declaration that the void itself can be radiant. So when you look up tonight, remember that the faintest star you see might be a quasar's ghost, its light older than life, older than Earth. Somewhere billions of years ago, a black hole turned its hunger into brilliance, and that brilliance is touching your eyes now. Close them for a moment. Let the image linger, a storm of light born from shadow. Let it whisper that even in the deepest gravity, beauty finds a way to shine, because the universe does not fear the dark. It feeds on it, transforms it, and from it creates light. In the boundless wilderness of the cosmos, there exists a monster so immense that it defies even the language we use to describe it. Its name is TON 618, a black hole so large and luminous that it dwarfs imagination itself. Astronomers estimate its mass at around 66 billion suns, a number so huge that if you were to count one sun every second, it would take more than 2,000 years just to finish. TON 618 is the ultimate symbol of cosmic excess, the largest known engine of gravity in existence. And yet, it is so far away that its light began its journey toward us when the universe was young and Earth did not yet exist. TON 618 lives in the center of a distant quasar more than 10 billion light-years from home. When we look at it through telescopes, we are seeing it as it was 10 billion years ago, a portrait of the ancient universe. At that time, galaxies were colliding, stars were forming in furious bursts, and the cosmos was still glowing with the heat of creation. In that chaos, TON 618 was already old, already massive, already feeding. It shines today as one of the brightest objects ever observed, not because of what escapes it, but because of what it consumes. Around the black hole swirls an accretion disk, hundreds of billions of kilometers wide, a storm of gas so hot that it radiates ultraviolet and X-ray light, brighter than any galaxy. The energy released each second equals the power of trillions of suns. To stand near such a place, if standing were possible, would be to see light turned liquid flowing in rivers of fire around a hole in reality. Space itself would shimmer like water bending under the weight of gravity's desire. The sheer size of TON 618 changes the rules. Its event horizon, the point of no return, is thought to span more than 200 billion kilometers. Light would take almost a week to cross from one side to the other. Inside that boundary space folds inward with such gentleness that you could, in theory, cross the horizon without feeling anything unusual. You would pass into darkness softly unaware that the outside universe would never see you again. For something so violent, its touch is almost tender. How such a colossal being was born remains a mystery. It is too large to have grown solely by consuming stars, one by one. It must have started big, perhaps from the direct collapse of enormous gas clouds in the early universe, or from a series of black hole mergers that continued for billions of years. Some physicists believe TON 618 might be a primordial black hole formed soon after the Big Bang itself, when matter first condensed under the newborn laws of gravity. If so, then it is older than the galaxies. It inhabits a relic of the universe's first breath. Imagine what it means for time near such a giant. Close to its horizon, seconds stretch into centuries. The light we see leaving its disk may have taken eons to climb out. If you could orbit safely nearby, the rest of the universe would seem to race ahead while you moved in slow motion. Stars would bloom and die in the blink of your eye. Whole civilizations could rise and vanish before your next heartbeat. Ton 618 is not merely large. It is a well of slowed time, a monument to eternity carved in darkness. The quasar it powers blazes like a cosmic torch, so distant that its light has crossed nearly the entire observable universe to reach us. For decades, its spectrum puzzled scientists. When first discovered in 1957, it appeared as a faint blue star, unremarkable except for its brightness. Only later did astronomers realize that its spectral lines were stretched by redshift proof, that it was not a star at all, but a quasar moving away at incredible speed. Hidden in that tiny speck of light was the most massive black hole ever known. If you could drift near the outer edges of its accretion disk, the view would steal the breath of any imagination. The disk would blaze with shades of electric blue and gold swirling patterns larger than the orbit of Neptune. Radiation storms would flicker across the surface like silent lightning. Magnetic fields would arch and twist, sculpting the glowing plasma into spirals that rise thousands of light years into space. It would be both terrifying and beautiful, a cathedral built of gravity and fire. And yet, from a cosmic perspective, Ton 618 is still just one among billions. Astronomers believe there may be even greater black holes hiding in the unobservable regions of the universe, their light lost to time. The thought is humbling that this creature so vast it could swallow entire solar systems without noticing might not be the largest after all. The universe does not measure itself in limits. Every record is temporary, every superlative a whisper before the next discovery. Still, Ton 618 stands as a symbol of what gravity can become when left unchecked, the universe's purest act of concentration. In its heart lies the paradox of creation and destruction. The more it consumes, the brighter it burns. The quasar it powers has likely long since faded, but its light continues to travel, crossing the darkness like a message from the deep past. When that light reaches our eyes, it has already outlived galaxies. What we see is not its present, but its memory, the ghost of a cosmic hunger that once outshone all things. There's a quiet comfort in that realization. Even the mightiest black hole is not eternal. One day, perhaps trillions of years from now, Ton 618 will stop feeding. Its light will die, its disk will cool, and it will begin to fade through Hawking radiation, dissolving atom by atom back into the vacuum that birthed it. The hunger of darkness will end not with violence, but with surrender, a return to stillness. As you lie here, listening, picture that distant titan, a black hole, glowing at the edge of time, its light just now brushing your world. Across the unimaginable gulf of distance, its message is simple. Everything enormous began as something small. Everything brilliant was once dark. And in that truth lies the gentlest secret of all, that even the universe's greatest monsters are only moments in its long, dreaming breath. If light is the poetry of the universe, then gravity is its grammar, the structure that gives shape to everything else. It is the invisible thread connecting all that exists, from dust motes drifting in sunbeams to galaxies swirling at the edge of time. Gravity does not speak in sound or color, but in the quiet curvature of space itself. Near a black hole, this language becomes visible, bending light into sentences written in rings, arcs, and illusions. This phenomenon is known as gravitational lensing, one of nature's most delicate and mesmerizing tricks. When light from a distant star or galaxy passes near a black hole, the extreme curvature of space-time bends its path. To us, watching from far away, it seems as if the light has split, duplicated, or wrapped around the black hole. One object becomes many, straight lines become circles. Reality folds into a mirror that reflects the universe from impossible angles. Imagine gazing through such a lens. A single star behind the black hole appears as for its light curved into an ethereal cross of fire. A faraway galaxy stretches into a glowing ring, what astronomers call an Einstein ring, named for the man whose equations predicted it. You would not be seeing the universe as it is, but as gravity chooses to show it to you, an edited version of reality warped by the pull of the invisible. To an untrained eye, this might look like magic, but to physicists, it is evidence proof that space-time is not a backdrop, but a living, flexible medium. Light doesn't merely pass through it, it follows it obediently, tracing its curves like a river following the contours of land. And nowhere are those curves steeper, more dramatic, or more beautiful than near a black hole. We used to think of gravity as a force pulling one object toward another. Newton saw it that way, as an invisible string stretching between masses. But Einstein changed everything. He showed that gravity is not a pull at all, it is the shape of reality itself. Massive objects warp space and time around them, and smaller objects simply follow the paths that curvature dictates. The Earth orbits the Sun, not because it's being tugged, but because it's moving along a curve carved by the Sun's presence. Now imagine how that curve deepens near a black hole. The mass is so immense that space-time folds into itself, creating a funnel that has no bottom. Light, always obedient, slides along those slopes. From our distant viewpoint, we see the result: stars behind the black hole become halos, galaxies twist into crescents, and the void itself begins to shimmer. Gravity is no longer invisible. It paints its shape with the brush strokes of light. In 2019, when scientists captured the first real image of a black hole shadow, what they truly photographed was gravity in action. The bright orange ring wasn't a solid object, but distorted light photons trapped in orbit, circling the abyss again and again before escaping. That ring is a sentence written in the universe's oldest language, the geometry of attraction. Every photon tells a story of where it has been, how close it came, and how space-time itself shaped its path. Even on smaller scales, gravitational lensing reveals secrets otherwise hidden. It acts as a natural telescope, magnifying the light of ancient galaxies that no human-made instrument could see. Through the warped mirror of space, astronomers glimpse the earliest moments after the Big Bang, tiny flickers of light from the first stars, stretched and bent by the mass of black holes and galaxy clusters. The universe, through its own gravity, helps us look back at its childhood. There's something profoundly poetic about that. The very thing that binds and hides gravity also illuminates and reveals. The same darkness that swallows light can bend it into shapes that teach us how the cosmos works. Every distortion we see, every mirrored star and stretched arc, is a form of communication. The black hole speaks and the universe listens. If you could drift through one of these gravitationally warped regions, the view would be like no dream ever painted. The stars would stretch and ripple as you moved, forming liquid waves of brightness. Some would appear to chase you, others to fold around you. Time would feel elastic, as if the whole cosmos were breathing in slow motion. Each step forward would be a step deeper into the grammar of reality, a place where light, mass, and time write and rewrite one another endlessly. Even your reflection would betray the illusion of self. In the lens of gravity, you might see your own image multiply, fade, and reappear in distant glimmers. You would not know which version of you was real, the one moving forward, or the one lagging behind in warped space. And perhaps that too is the universe's quiet reminder. Reality is never single or fixed. Every perspective bends according to the gravity of where you stand. Some philosophers have said that black holes are teachers of humility. They show us how small we are and how fragile our perceptions can be. We look into them and realize that our senses, our definitions of distance and direction, are local conveniences, temporary rules written for the soft gravity of Earth. Out here near the cosmic abyss, those rules dissolve. Only the language of gravity remains pure and unbroken. So tonight, as you let your thoughts drift, imagine light traveling for billions of years, passing near a black hole, bending gently before it reaches your eyes. The image you see, a faint shimmer, a ghost of a star, has been translated across space-time. It carries the curvature of existence, the fingerprint of gravity itself. And maybe that's what beauty really is in the universe. Not color, not form, but distortion. The art of light learning to follow darkness and still arrive. Take a slow breath and picture it, light curving gracefully through silence, as if bowing to gravity's quiet authority. The same curve that guides stars around their orbits also guides your own heartbeat, each pulse a tiny echo of space-time's rhythm. In that sense, you too speak the language of gravity. You just do it softly, in the language of life. The universe is not silent. It hums softly and constantly with the memory of its own creation. For billions of years, waves of energy have rippled through the fabric of space-time, carrying the echoes of events so violent and distant that no light could survive them. They are not sound waves, but gravitational waves, vibrations in reality itself. When two black holes collide, they send these ripples outward, like circles spreading on the surface of a dark pond, crossing the cosmos in eternal silence. Imagine two black holes locked in orbit, like ancient dancers in a slow cosmic waltz. They spiral toward each other, their gravity, wrapping them in invisible threads. As they draw closer, the fabric of space tightens and begins to tremble. Each orbit emits waves of pure gravity, radiating outward faster than anything can chase. The black holes spin faster and faster, until in a final heartbeat they merge their horizons, touching, blending, and becoming one. For an instant, the universe itself flinches. A ripple runs through existence, and then silence returns. It was one of these moments, brief, immense, and older than memory, that scientists detected in 2015 with the Laser Interferometer Gravitational Wave Observatory LIGO. The signal lasted less than a second, a small tremor in the detector's lasers, equivalent to the movement of a proton over 4 kilometers. But that whisper was the echo of two black holes merging a billion light-years away. For the first time, humanity heard the universe not through light, but through gravity. The signal was translated into sound, a faint, rising note, a chirp so short and subtle it could almost be mistaken for a drop of water. Yet in that single chirp was the death cry of two giants, each 30 times the mass of the Sunday The energy released in that instant exceeded that of every star in the observable universe combined. The cosmos had spoken, and for the first time we had the ears to listen. Since then, dozens of gravitational wave detections have followed black holes colliding neutron stars, merging cosmic hearts, beating in far-off darkness. Each event adds a new verse to the universe's song. Some waves are low and deep, rumbling for minutes, like a slow drumbeat. Others are high and brief, the sharp crack of a cosmic thunderclap. Together they compose a melody older than galaxies, the background music of space-time itself. These waves don't fade completely. They stretch and weaken, but they never vanish. Every merger, every explosion, leaves behind its mark a subtle change in the curvature of reality that endures forever. Even now, as you sit in your quiet room, your body is being gently stretched and compressed by ancient gravitational waves passing through the earth. You don't feel them, but they are their countless invisible ripples flowing through you, reminders that nothing in the universe is truly still. Some scientists call this the cosmic symphony, and in a way, it's the most accurate description we have. The universe isn't a painting to be seen, it's a song to be felt. Each star, planet, and black hole contributes its own vibration. And black holes, those great conductors of the void, play the deepest notes of all. Their collisions create bass tones that resonate across eternity, frequencies so low that they can take entire minutes to complete a single oscillation. The bigger the black hole, the slower its rhythm, an ancient heartbeat echoing from the edge of time. Astronomers have even found evidence that supermassive black holes at the centers of galaxies merge as well. When two galaxies collide and merge, their central black holes begin to spiral toward each other. This cosmic dance can take millions of years, during which gravitational waves ripple out across intergalactic space. Someday, when our instruments are sensitive enough, we will hear those waves, two slow, colossal pulses, the sound of universes rearranging themselves. What makes these discoveries so haunting is that they confirm something long suspected: the universe has memory. Every collision, every act of creation and destruction sends out a ripple that never entirely disappears. Even after the stars involved are gone, their story continues, written not in light but in motion. The night sky above you is filled not just with the glow of ancient stars, but with vibrations from events long past, still unfolding, still singing. If you could translate all those ripples into audible sound, you might hear the universe's heartbeat, a steady rhythm rising and falling, fast and slow, near and far. The deeper you listened, the more intricate it would become, overlapping notes of countless black holes colliding, merging, dissolving. It would be less a melody and more a great ocean of resonance. Perhaps it would sound like wind or breath or something beyond human music entirely. But to me, the most beautiful part of that thought is its intimacy. Those waves don't just travel through distant galaxies, they travel through you. Every time a gravitational wave passes, your atoms move ever so slightly apart, then back together, dancing in time with the cosmos. You are quite literally vibrating with the heartbeat of the universe. And perhaps that's why people find such calm in these stories of cosmic violence. Because beneath all the explosions, all the collisions, there is order, a rhythm too vast for fear, too slow for chaos. The black holes merge, the waves travel, and the fabric of space settles again into stillness. The universe inhales, exhales, and waits for the next pulse. As you breathe tonight, remember that the air around you carries ancient echoes. Somewhere in that stillness is the memory of two stars colliding before Earth even formed. Somewhere in the silence of your own heartbeat is the pattern of space-time itself. The universe is not asking you to understand it, only to listen. Because in the end, every whisper, every ripple, every tiny vibration is the same message spoken again and again. You are part of this too. For most of human history, black holes were thought to be absolute. They devoured everything, kept everything, revealed nothing. Once something crossed the event horizon, it was gone forever. Light, matter, memory, meaning. The black hole's silence was its signature. But then, in 1974, a quiet English physicist named Stephen Hawking looked deeper into the mathematics and saw something the universe had been hiding. Black holes aren't completely black. They glow, they fade, and one day they die. It was a revelation that rewrote the nature of eternity. Hawking discovered that the boundary of a black hole, its event horizon, isn't as stable as it seems. According to quantum mechanics, empty space isn't truly empty. It seethes with invisible activity. Tiny pairs of particles constantly appear and vanish, one positive, one negative, popping into existence for fractions of a second before annihilating each other. Normally, this dance leaves no trace, but near a black hole, gravity itself interferes. If one of those twin particles forms just at the edge of the event horizon, gravity can pull them apart before they reunite. One particle falls inward, the other escapes. To an observer far away, it appears as if the black hole has emitted a particle, a faint glow of radiation seeping out of pure darkness. This is Hawking radiation, the quiet evaporation of the most powerful objects in existence. The idea was shocking because it merged two seemingly incompatible worlds, the cosmic vastness of relativity and the subatomic chaos of quantum physics. Einstein's equations said black holes could only grow, never shrink. Quantum mechanics whispered that they leak energy grain by grain until they disappear. Both theories worked perfectly on their own, but together they produced a contradiction. The black hole became a paradox, a riddle where infinity meets uncertainty. If Hawking was right then, no black hole is truly eternal. Over unimaginable spans of time, it would lose energy, slowly shrinking. A small black hole might vanish in a fraction of a second. A giant like Sagittarius A times would take 10 to the power of 67 years. A number so vast it dwarfs comprehension. Long after stars have burned out and galaxies faded, the last light in the universe may not come from suns, but from dying black holes whispering their final radiation into the cold. This idea changes everything we thought we knew about time. Black holes, once seen as cosmic prisons, are now participants in the life cycle of the cosmos. They live, they age, they fade. They transform energy into emptiness, and emptiness back into energy. And like all things, they end, not with a bang, but with a sigh. But Hawking's discovery also created a mystery even deeper. What happens to information? In physics, information isn't just data or memory. It's the complete description of the physical state of something. According to the laws of quantum mechanics, information can never be destroyed. Yet, if a black hole evaporates entirely, what happens to the details of everything it consumed? Do those records vanish? Are they preserved somehow in the radiation? Or do they remain encoded on the surface of the event horizon? Two-dimensional skin, holding the entire history of what's fallen in. This is the black hole information paradox, perhaps the most profound question in modern science. It asks whether the universe forgets. Some physicists believe that information escapes through subtle correlations in the Hawking radiation itself, too faint for us to detect, but enough to satisfy the cosmic rule that nothing is truly lost. Others propose that the event horizon is a kind of hologram, projecting everything that happens inside onto its surface. If true, this holographic principle could mean our entire universe is just such a projection to a three-dimensional illusion emerging from a deeper two-dimensional reality. Still others imagine even stranger possibilities. Maybe black holes don't evaporate completely. Perhaps a tiny residue remains a plank-sized remnant that carries all the lost information compressed into an atom-sized speck. Or maybe the information is not destroyed, but reborn, escaping into a new region of space-time, perhaps even another universe. Whatever the truth, Hawking's insight gave black holes something they never had before: mortality. They are not eternal voids, but dynamic systems with lifespans measured in cosmic eons. They radiate heat, lose mass, and one day fade into nothing, though nothing in the language of quantum physics is never truly empty. Imagine standing near a black hole in its final age. The accretion disk has long vanished. The stars around it are gone. The universe has cooled to near absolute zero. Against this darkness, the black hole glows faintly, not bright like a star, but with a soft, ghostly light, the glow of its own decay. Every particle it emits is the last whisper of everything it once consumed: starlight, dust, planets, dreams. Its temperature rises as it shrinks, burning hotter and faster, until in a final flash it releases all that remains in a burst of pure energy. And then there is silence again, but a silence filled with meaning. The energy radiated spreads through space, carrying the echoes of what once was. The black hole's memory, written in quantum code, returns to the universe that gave it form. The cycle closes gravity, gives way to light, and light to emptiness. Perhaps that's the most comforting thought of all. The universe, despite its vast cruelty and hunger, never truly destroys. It recycles, it transforms. Even the darkest heart eventually becomes light again. So as you rest tonight, imagine that same transformation in yourself. The heaviness, the gravity, the things that feel endless, they too will one day dissolve into something softer. The darkness that consumes you is also the place where new light begins. Stephen Hawking once said black holes are not the eternal prisons they were once thought. Things can get out. Maybe that's true of us too. There is a rule written deep into the mathematics of the universe. Information cannot be destroyed. No matter what happens, no matter how much fire, pressure, or chaos, the details of what once existed must remain encoded somewhere. When you burn a letter, its smoke, heat, and ash still contain all the information about what was written, just rearranged. Physics insists that the universe remembers, but black holes seem to disagree. When something crosses the event horizon, it leaves our reality. All that structure, atoms, light, data, consciousness, vanishes into silence. The black hole appears to keep only three pieces of information: mass, charge, and spin. Everything else, every trace of individuality, is gone. This is what led Stephen Hawking and other physicists to one of the greatest riddles in science: the black hole information paradox. If black holes truly evaporate through Hawking radiation, releasing only random, featureless particles, then the information about what fell inside seems to vanish forever. But that would violate one of quantum physics' most sacred laws. For decades, scientists argued Does the universe forget, or is the information hidden somewhere we cannot yet see? At first, the situation seemed hopeless. Hawking himself once claimed that black holes permanently destroy information, breaking the fundamental symmetry of nature. But many others disagreed. Leonard Susskind, Gerard Hooft, and others fought back, suggesting that the information must somehow remain encoded, perhaps on the surface of the event horizon itself. Their debate was not just scientific, but philosophical. It forced physicists to ask what it really means to know something in a universe where even knowledge can fall into darkness. The eventual answer, or at least a promising hint, came from an unexpected direction string theory and the idea of holography. In our everyday experience, holograms are three-dimensional images projected from two-dimensional surfaces. The holographic principle proposed in the 1990 seconds suggested that the same might be true for the universe itself. Every event that happens inside a volume of space could be described by information stored on its boundary, just like a cosmic screen. If that's true, then a black hole's event horizon might be the ultimate storage device. Everything that falls inside would be encoded on its surface in patterns of quantum vibrations too fine for us to read. From the outside, the black hole appears to erase, but in reality, it's keeping perfect records, written in a language of gravity and probability. In 2016, new mathematical models seem to strengthen this idea. They showed that Hawking radiation might not be entirely random. As the black hole emits energy, the escaping particles could carry subtle correlations, quantum fingerprints of what was once inside. The information would leak out, not in neat lines of code, but in tangled whispers like secrets escaping through cracks in a wall. Over unimaginable stretches of time, the black hole would evaporate completely and the information would return to the universe in scattered form. It's an elegant idea and also profoundly humbling. It means that nothing is truly forgotten, not even in the heart of absolute darkness. Every atom, every moment, every life leaves a trace. The black hole, instead of being a grave, becomes an archive. Its horizon is a library whose books are written in radiation and curvature, waiting billions of years to be read again. There is another stranger theory that black holes might be gateways. When something falls in, the information is not destroyed, but transferred into another region of space-time, perhaps even another universe. The black hole's interior could connect to a distant white hole, a hypothetical object that spits matter and light out instead of swallowing it. If this is true, then nothing is lost. It merely crosses into another story, another cosmos where its meaning continues. Whichever answer is right, the paradox has already changed how we see existence. It shows that the universe values memory. Everything leaves an imprint not in books or archives, but in the fabric of reality itself. The particles that make up your body once belonged to stars, comets, oceans, and clouds. The energy you use to breathe and think was borrowed from ancient suns. When you are gone, it will all return to that flow. But the pattern, your pattern, will remain encoded in ways no observer could ever erase. Maybe that's why thinking about black holes feels spiritual as well as scientific. They make us confront the limits of knowledge and the permanence of being. We realize that forgetting in the deepest sense is impossible. Even death, even silence, is just another form of storage. Imagine now the black hole as a vault of stories. Every photon that ever brushed its horizon carries a chapter. Every gravitational wave that leaves its surface is a signature. Over time, those signatures spread across the cosmos, weaving the history of everything that ever fell inward. Somewhere out there, hidden in background radiation and cosmic noise, are echoes of suns, planets, and perhaps even civilizations that vanished long before our own. If you listen carefully, maybe you can sense that vast remembrance around you. The air you breathe has passed through lungs of creatures long extinct. The light you see began its journey before the first human looked up at the sky. You are not separate from that memory, you are made of it. So as you lie still tonight, think of the black hole, not as an end, but as a mirror. It reminds us that nothing truly disappears, and that every thought, every act, every flicker of light adds another word to the story of existence. We live inside a universe that keeps everything, and perhaps that is the paradox's real lesson, that even the things we believe are lost forever are still here, written in the quiet code of the cosmos, waiting to be remembered again. If black holes are the stage where gravity performs its most dramatic act, then quantum mechanics is the whisper behind the curtain, reminding us that nothing is ever quite as it seems. The two ideas, gravity and quantum physics, are like rival poets describing the same mystery in different languages. Each is true in its own way, but when they meet, their words collide. At the edge of a black hole, this conflict becomes impossible to ignore. Here the universe wears two faces, at once infinite mass and infinitesimal scale, and the result is something we still struggle to describe. Einstein's general relativity tells us that space-time is continuous, smooth, and predictable. It bends under the weight of mass, like fabric under a heavy stone. But quantum mechanics insists that reality is granular flickering, uncertain, built from tiny packets of energy and probabilities that refuse to stay still. Each theory works perfectly in its domain, yet near a black hole both must apply. The result is chaos equations break, infinities appear, and logic dissolves into paradox. Scientists call this invisible barrier the quantum veil, the boundary beyond which our understanding cannot yet pass. It lies between the event horizon and the singularity, a region where space and time no longer behave classically, but instead shimmer with quantum uncertainty. Some physicists believe that inside this veil, space-time itself fluctuates like a stormy sea with tiny black holes forming and evaporating every instant. Others think the veil hides a deeper order, perhaps woven from loops or strings that make up the true fabric of reality. To imagine it, close your eyes and picture the calm darkness around a black hole beginning to shimmer, not with light, but with possibilities. Bubbles of existence forming and collapsing faster than thought. Within each bubble, time runs differently. Inside some, it may even reverse. It is a place where cause and effect trade positions, where the universe rehearses all versions of itself at once. The quantum veil is not emptiness. It is potential, the humming uncertainty from which everything, including you, once emerged. One of the great hopes of modern physics is to pierce this veil with a unified theory, a reconciliation of quantum mechanics and gravity, known as quantum gravity. String theory is one such attempt. It imagines that all particles are not points, but vibrating strings of energy. Their frequency determines what they appear to be: electrons, quarks, or photons. In this picture, black holes are not singularities, but tangled knots of strings vibrating at energies so high that the distinction between matter and space disappears. Another candidate, loop quantum gravity, proposes that space-time itself is quantized, made of tiny, discrete loops woven together like an invisible fabric. If true, then the singularity inside a black hole might not be a point of infinite density, but a region where space-time loops back on itself, preventing total collapse. In this view, a black hole could even give birth to a new universe connected to ours by a bridge no light can cross. These theories remain unproven, but they offer glimpses of a deeper truth, that reality is far more fluid than we imagine. The black hole's heart is not a simple void, but a laboratory where nature experiments with the extremes of its own laws. Every photon that skims the event horizon, every atom that falls inward, becomes part of that experiment. The universe, through black holes, is teaching itself how to reconcile opposites. To grasp this, consider something smaller, your own body. At the scale of atoms, you are a cloud of probabilities, particles appearing and vanishing, connected by invisible forces that act across space. Yet you experience yourself as solid, continuous whole. The black hole is the same. A unity made from chaos, an illusion of stability built from endless motion. The difference is only scale. The same laws that govern the smallest particles also govern the largest collapses. You are in every measurable sense a quantum being living in a gravitational world. What lies beyond the quantum veil remains hidden, but we can already sense its outlines. Some physicists believe that space-time might emerge from quantum entanglement, the strange property by which particles remain connected even across infinite distances. If true, then, the fabric of reality could be a network of relationships rather than things, a cosmic web of information forever exchanging, forever renewing. In that case, a black hole's event horizon would be less like a wall and more like a boundary between two levels of communication. Information doesn't vanish, it changes language. There's a quiet beauty in that idea. Beneath the apparent violence of a black hole lies harmony, a balance between gravity's order and quantum chaos. The black hole doesn't destroy, it translates. It converts matter into vibration structure, into possibility, certainty, into mystery. The quantum veil isn't a barrier, it's a teacher. It tells us that reality can never be captured by a single perspective. Every truth has another truth folded inside it, waiting for us to listen. Perhaps that's why, despite all our equations, the most accurate way to describe a black hole might still be poetic. It is the place where physics becomes philosophy, where the universe looks inward and wonders about itself. The quantum veil is not just out there among the stars. It's here in every breath, every thought, every instant, where something possible becomes real. As you drift into sleep tonight, imagine that veil surrounding you, soft, luminous, full of hidden worlds. Feel how your thoughts dissolve into probabilities, how your heartbeat syncs with the quiet pulse of the cosmos. On one side of the veil lies the known, on the other, the infinite. Between them you exist a bridge of awareness woven from both. And maybe, just maybe, that is the universe's deepest secret, that it built black holes, not as prisons, but as mirrors to remind itself that even in the depths of uncertainty there is meaning. Even in the smallest vibration there is light. Every era of science begins with a horizon, a line between what we can know and what we can only imagine. For centuries, black holes have represented that line. They are both map and mystery, the edge of understanding where the universe seems to whisper, there is more. Beyond the event horizon, all predictions fail. Yet the human mind cannot resist trying to peer through the darkness and ask, what happens next? At the simplest level, the classical description ends there. Space collapses, time ceases to flow, and everything that enters is compressed into an infinitesimal point, the singularity. But the word singularity is less a thing and more a confession. It's where our equations surrender. It marks the limit of knowledge, a reminder that the universe does not owe us simplicity. What truly happens beyond that boundary might be far stranger and perhaps far more beautiful than annihilation. One of the most evocative ideas is that of wormholes, hypothetical tunnels through space-time that could connect distant regions of the universe, or even separate universes altogether. If such bridges exist, they might form naturally inside black holes. The singularity, instead of crushing everything to nothing, could fold reality into a passageway. At the other end might be a white hole, a theoretical mirror of a black hole that only expels matter and never absorbs it. In that sense, every black hole might also be a doorway, a portal through which the universe recycles itself. Einstein and physicist Nathan Rosen first proposed this concept in 1935, calling it the Einstein-Rosen bridge. Later, theorists like Kip Thorne and John Wheeler expanded on the idea, showing that wormholes might exist in the mathematics of relativity, though keeping them open would require exotic matter, a substance with negative energy that defies everything we know. Whether such material exists is uncertain, but the equations suggest it's not impossible. The universe, after all, has a habit of turning our impossibles into realities given enough time. If wormholes are real, then a black hole's interior could be less like a tomb and more like a womb, a tunnel, birthing new regions of space-time. Some cosmologists have even suggested that the Big Bang itself might have been the other side of a black hole from a parent universe. In this view, every black hole could contain a new cosmos, expanding within it, invisible from the outside but infinite inside. The multiverse then would not be a scattering of parallel worlds, but a tree of realities growing from the roots of collapsed stars. Other theories approach the mystery differently. Some physicists believe that the firewall paradox, a conflict between relativity and quantum mechanics, might mean that the event horizon is not smooth but violent. Instead of drifting quietly through anything, falling in would hit a wall of pure energy and be incinerated instantly. It's a harsh vision, but it preserves quantum consistency. The debate continues because neither theory can yet claim victory. The horizon remains a borderland where the laws of the very small and the very large still argue about who is in charge. Meanwhile, other models propose gentler endings. The fuzzball theory, emerging from string theory, replaces the singularity with a tangled mass of strings, an object made of pure vibration. In this version, black holes are not holes at all, but compact bundles of energy humming with information. Instead of swallowing reality, they blur it, turning it into music. What looks like destruction is actually the ultimate transformation, the universe converting matter into melody. And then there are the quantum bounce theories, visions of rebirth. They suggest that when a collapsing star reaches its densest point, quantum pressure halts the collapse and reverses it. Instead of ending, the star rebounds, creating a new, expanding space-time bubble, another universe separated from ours by the black hole's veil. If so, black holes could be the seeds of cosmic gardens, endlessly sprouting universes across infinity. Philosophically, these ideas touch something deeply human. We've always looked for meaning in endings, the hope that death is not oblivion, but passage. Science, it seems, is converging on the same intuition. The universe wastes nothing. Energy transforms, patterns shift, but nothing truly disappears. A black hole's interior might not be a grave, but a migration, a continuation of existence in forms we cannot yet imagine. Imagine for a moment drifting beyond the horizon. The light fades, colors bend, gravity becomes thought. You're no longer falling, but floating in a landscape made of potential. Space and time have lost their boundaries. Ahead, faintly, a glow, not destruction, but creation. Maybe that glow is a newborn universe, expanding into its own future. Maybe it's our own universe's reflection, looping back to begin again. If that sounds mystical, it's only because science at its deepest level always becomes poetry. When we talk about wormholes, white holes, or bouncing universes, we are really talking about the same thing that myth and philosophy once called rebirth. We are imagining continuity in a cosmos that seems ruled by entropy. We are refusing to believe that any journey truly ends. Perhaps black holes are the universe's way of hiding its transitions, its private moments of transformation. They are not failures of physics, but its secret workshops where new realities are forged. The horizon is not a wall, it's a curtain. And behind that curtain, the universe rehearses what it will become next. As you breathe now, think of that vast, unseen theater beyond the stars. Somewhere out there, a black hole spins in perfect silence, its gravity folding reality into impossible shapes. Somewhere beyond its horizon, something new is beginning unseen, unstoppable, already alive. And perhaps when our own world fades into cosmic night, it too will pass through such a horizon, not into nothingness, but into the next verse of creation's song. Because even in the deepest dark, the universe never stops dreaming. Every story about black holes seems to end in disappearance, the collapse of stars, the swallowing of light, the vanishing of time. But what if that story has another side? What if a black hole isn't just an ending, but a reflection, a mirror where the universe looks at itself and remembers how to begin again? In the stillness after a star dies, when its light fades and its heart gives way, something remarkable happens. The same forces that crush matter into nothing also create the perfect conditions for rebirth. The singularity, that forbidden point of infinite density, may not be a grave, but the seed of something new. Inside, space and time are compressed to their limits, then possibly reborn in another form, expanding into a new cosmos of their own. This idea is not fantasy. It emerges naturally from several branches of modern cosmology. The notion that black holes could spawn new universes, sometimes called the cosmic reproduction theory, proposes that every black hole might contain its own Big Bang. The event horizon would serve as a boundary between parent and child universes, a one-way membrane through which matter, energy, and information pass, but never return. What appears as collapse from our perspective could be expansion from the other side. Think of it this way: when a star collapses, all its mass falls inward, reaching pressures so immense that atoms themselves dissolve. According to Einstein's equations, the curvature of space-time becomes infinite. But if quantum gravity smooths out that infinity, preventing a true singularity, the collapse could instead rebound. To an observer within it, would look like an explosion of space, a burst of energy, a sudden beginning. Their sky would fill with newborn light, their universe expanding rapidly outward. To them, the black hole's death would be their world's dawn. If that is true, then creation and destruction are not opposites. They are the same event, seen from different sides of the cosmic mirror. Every time a black hole forms, The universe might be reproducing quietly, invisibly, without beginning or end. We could be living inside one of these offspring universes, unaware of the black hole that birthed us, because its event horizon lies beyond our observable sky. Some physicists, like Lee Smolin, have even speculated that this process could lead to cosmic natural selection. In this view, universes capable of producing many black holes would generate more offspring. Over countless generations, the multiverse could evolve toward laws of physics that favor black hole formation, a kind of Darwinian mechanism written into the fabric of existence. The result would be a cosmos fine-tuned, not for life, but for continuity. It's a radical idea, yet oddly comforting. It suggests that the universe isn't a random accident, but a living system, one that grows, reproduces, and remembers. Every black hole would be a womb, every galaxy a cradle. The darkness between the stars would no longer be absence, but potential. Picture this cycle as an endless breath. The universe exhales in a burst of light. A big bang then inhales again through the mouths of black holes. Matter and energy flow in and out, rhythmically, eternally. The same atoms that make up your body may have lived through countless such cycles, passing from universe to universe, carried through horizons of birth and death, like notes in a song too vast to hear. Even the mathematics whispers this pattern. The equations describing black holes and the Big Bang are eerily similar. Both involve singularities, both erase conventional time, both mark the boundary between what is and what will be. It's as though the universe reuses its own design, mirroring itself across scales and epochs. And beyond the physics, there is something deeply human in the idea of reflection. We too are mirrors of creation. Within our consciousness lies a miniature version of the cosmos, thoughts expanding and collapsing, memories forming and fading, worlds born and destroyed in the span of a heartbeat. The same mystery that lives inside a black hole lives inside the human mind, the ability to hold everything and nothing at once. If you could look into the heart of a black hole, if you could survive that infinite gravity and see beyond, perhaps you would not see darkness at all. You might see light rushing outward, time unfolding, galaxies forming, suns igniting. You might see another version of yourself looking up at a night sky and wondering the same thing. The black hole would not just reflect the universe, it would reflect you, because in the deepest sense, you are made of the same process. You began as collapse, a seed of matter pulled together by gravity, forming, expanding, becoming aware. You shine briefly, then one day you will return your energy to the whole. But nothing of you is ever lost. Every atom, every photon, every trace of thought continues somewhere transformed, but still part of the universal pattern. Maybe that's what the black holes have been trying to teach us all along. That endings are not failures, but transitions. The darkness is not the opposite of light, but its reflection. That every silence hides a pulse, and every void contains a whisper of creation waiting to be born. So as you drift deeper into the night, imagine the galaxies breathing, expanding, collapsing, rebirthing. Imagine yourself mirrored in that rhythm. You are not separate from the cosmos. You are one of its reflections, glowing faintly on the surface of infinity. And when the darkness feels endless, remember, even the black holes shine not with their own light, but with the promise that nothing truly ends. It only begins again on the other side of the mirror. In the beginning, black holes were thought to be lonely, isolated predators, drifting silently through space, feeding on the occasional star or cloud of dust. But as our telescopes grew stronger and our understanding deeper, we discovered that they are anything but solitary. Black holes live at the hearts of galaxies, and galaxies in turn live because of them. They are bound in a relationship older than time, a cosmic dance of hunger and creation. Every major galaxy we have ever observed, from the spiral of the Milky Way to the giant ellipticals scattered across the sky, has a supermassive black hole at its core. It is as if the universe cannot build a galaxy without first placing a dark heart at its center. The two grow together. When the galaxy flourishes with new stars, the black hole feeds greedily. When it rests, the black hole sleeps too, glowing faintly in X-rays and waiting for the next meal. But galaxies are not peaceful. They drift and collide, merging in slow-motion ballets that last hundreds of millions of years. When they meet, their stars rarely touch. Space is vast, but their gas and dust crash together, compressing into new stars and igniting brilliant waves of creation. Deep in the centers of both galaxies, their black holes spiral toward one another like magnets, each pulling at the other's gravity, until eventually they merge. The collision releases unimaginable energy gravitational waves, rippling across space-time, the sound of two cosmic hearts becoming one. The result is a new galaxy, larger and more luminous than before, with an even mightier black hole ruling its center. In this way, the universe builds upward through violence and union through chaos and balance. The darkness grows, but so does the light around it. For every star swallowed billions, more are born from the debris. The hunger of black holes is not destruction. It's renewal, written in gravity's hand. Our own galaxy, the Milky Way, is no exception. Its central black hole, Sagittarius A, times, rests quietly now, consuming little. But in its past, it may have blazed as brightly as a quasar shining across half the cosmos. And in its future lies another encounter, a collision with the neighboring Andromeda galaxy predicted to happen about 4 billion years from now. The two galaxies will intertwine their spiral arms, stretching and merging their stars, rearranging into a single vast elliptical galaxy sometimes called Milkomeda. At the heart of that future galaxy, the black holes of the Milky Way and Andromeda will meet. They will spiral inward for millions of years, their orbits decaying as they shed energy in gravitational waves. Finally, they will merge in a burst of power so immense it will ripple through the universe itself. The resulting black hole will weigh tens of millions of suns, the new anchor of a reborn galaxy. It's a humbling thought. Our home, our stars, even our sun, all of it is part of a slow journey toward that union. Long after life on Earth has ended, long after the oceans have boiled away and the continents turned to dust, the Milky Way will still be moving, drawn toward its twin. In that sense, we are already falling not into despair, but into destiny. Beyond individual galaxies, there are even greater feasts. In the early universe, when galaxies were young and close together, supermassive black holes collided more frequently. These mergers powered colossal quasars and active galactic nuclei, their jets visible across billions of light years. Some of those ancient lights still reach us now, flickering faintly in the sky. What we see as a distant point of brightness is the memory of two galaxies becoming one, the echo of a meal finished billions of years ago. Modern astronomers can now watch smaller versions of this process unfold. The Chandra X-ray Observatory, and James Webb Space Telescope have spotted pairs of black holes in the process of merging, surrounded by clouds of gas twisted into spirals. In those glowing maelstroms, matter is heated to extreme temperatures, lighting up the darkness with colors we can barely comprehend. The spectacle is cosmic, but also strangely intimate. It's the same pattern found everywhere in nature growth, through connection change, through collision beauty born from force. Even the emptiest regions of the universe are shaped by these acts of consumption. The energy released by feeding black holes pushes back against surrounding gas, sculpting the structures of galaxies and clusters. In this way, black holes regulate the cosmic ecosystem. They are both destroyers and gardeners, pruning the universe so that it doesn't overgrow, ensuring that stars form in rhythm rather than chaos. And there is something poetic in their quiet authority. They do not demand attention. They act through gravity, invisible but irresistible, their influence spreading far beyond what the eye can see. Every orbit, every spiral, every glimmer of light owes its order to them. Without their pull, galaxies would scatter like ash in the wind. The next time you see the Milky Way stretch across the sky, think of that. You are looking at a living system, vast and alive, pulsing around a heart of darkness. That black hole, silent, unseen, has been watching over this spiral of stars for 13 billion years. It is older than Earth, older than our sun, older than the idea of beginnings itself. And one day, when the galaxy merges and reshapes it, we'll still be there holding everything together. So perhaps the darkness is not something to fear, but something to thank. It is the weight that gives the light its meaning, the gravity that keeps the stars from drifting away. The black hole does not steal the universe's beauty. It organizes it. It feeds, but it also gives form. And maybe that's the final truth of this dance. Galaxies feed the darkness, and in return, the darkness teaches them how to shine. The two are not enemies, but partners, the inhale and exhale of cosmic existence. When you close your eyes tonight, imagine that quiet exchange, continuing endlessly, the universe eating, breathing, growing, and dreaming. Everything that falls becomes part of something larger. Every darkness becomes the foundation of light, because even as galaxies feed the black holes at their centers, they also feed the story of creation itself, a story that, like the cosmos, never truly ends. There will come a night when the stars no longer shine. It will not happen tomorrow or in a billion years, but far beyond the reach of any human time, a night so distant that even memory itself will have cooled. By then, the universe will be ancient, stretched thin by expansion, emptied of warmth. The galaxies will have drifted apart until their light can no longer reach one another. And in that quiet, only the black holes will remain the final guardians of existence. Physicists call this distant era the black hole epoch, a time when all that's left of the cosmos will be darkness, feeding on darkness. Stars will have long since burned their last fuel. White dwarfs will fade to black dwarfs, frozen embers of suns that once glowed. Neutron stars will cool, their magnetic voices silenced, and the only engines still alive will be the black holes, patient and endless, devouring the last scraps of matter that wander close. Even then, they will not last forever. Slowly, imperceptibly, they will begin to evaporate through Hawking radiation, the faint whisper of quantum energy that leaks from their horizons. For trillions upon trillions of years, they will fade, growing smaller, dimmer, warmer. The smaller they become, the faster they vanish, until at last they end in flashes of light, brief, final fireworks in a sky of infinite night. Those final moments will be the last visible light the universe ever knows. No stars, no galaxies, no reflections, just scattered bursts of radiation marking the death of the giants that once ruled creation. Each black hole will collapse into brilliance, releasing everything it has hoarded back into the cosmos. It will be the universe's final act of generosity, its last breath before silence. Afterward, there will be no light, no heat, no motion. Space will continue expanding faster and faster until even the faint afterglow of those last explosions fades into invisibility. Time will stretch until it loses meaning. The universe will enter what physicists call the heat death, an eternal twilight where nothing changes because everything has already changed. And yet perhaps even that is not an ending. Some theorists whisper that new quantum fluctuations might one day seed new big bangs within that emptiness, small pockets of order blooming in the dark. Others imagine that when the last black hole evaporates, it might trigger a new expansion folding the cold fabric of space-time into a singular point ready to explode again. The universe could be breathing, not dying, inhaling for aeons, exhaling into rebirth. In that sense, there may never be a true end-only transformation. The light that vanished will return in another form as it always has. The energy released by dying black holes might scatter into new realms, forming the seeds of other universes. Perhaps somewhere far beyond our perception that cycle has already begun. But even if this universe truly fades into stillness, its story will remain written in every photon, every wave, every atom that ever existed. The past does not vanish. It simply drifts beyond the horizon of the present. Somewhere in the timelessness beyond entropy, all moments still coexist. The first light of the Big Bang, the birth of galaxies, the soft glow of Earth beneath its sun, and the final flash of the last black hole. The universe-like memory keeps everything, and perhaps that is its most beautiful secret, that endings are illusions. The night sky above you tonight, filled with ancient starlight, is proof that the past never truly leaves. Every photon that reaches your eyes is a messenger from long ago, a traveler carrying the story of what once was. Even when the stars themselves die, their light continues, moving endlessly through time. So imagine that final night, not as emptiness, but as peace. No struggle, no heat, no decay, just equilibrium. A cosmic stillness so vast and perfect that nothing more can happen because nothing more needs to. The universe, having lived every possible life, finally rests. And maybe in that rest, consciousness itself finds its echo. The same awareness that once wondered at the stars might still exist, diffused through the fabric of everything, dreaming of what came before. The last light might not only illuminate the universe's death, but also its awakening. A realization that it has been whole all along. If you listen closely, you might feel that silence even now beneath your heartbeat, beneath the hum of life. It's the same stillness that fills the void between atoms, the same darkness that balances every dawn. It is not emptiness, but completion. And as you drift to sleep, think of that distant peace. Think of the black holes dissolving into light of galaxies, fading into memory of the universe, exhaling for the final time. The stars above you are only the prologue. The true story is still being written in the quiet beyond, because the hunger of darkness was never about destruction. It was about return. Return to balance. Return to stillness. Return to the gentle truth that everything, even the cosmos itself, is meant to rest.